Okay, well, here we just review what we did in preceding couple of videos, which I hope you watched, but just very briefly, if W is the length of a rectangle and W the width and L the length of a rectangle, the perimeter is 2L plus 2W. And the problem we're looking at, the perimeter is 400, so 2L plus 2W is 400. We can solve for L. We get 400 minus 2W, all divided by 2 is 200 minus W. Very straightforward. Alternatively, half the perimeter would be just L plus W. Okay, just this plus this gives us half the perimeter, and half of 400 is 200, so L plus W is 200, and very directly L is 200 minus W. Simple equation to solve. Of course, this might be more reliable if you're relying on formulas, but if you rely on understanding the whole idea of perimeter, you can skip directly to this, or even just directly to this. Okay, anyhow, width W, length 200 minus W gives us area, width times length, 400 minus 2W over 2, that's length, times width. And length times width is the same as width times length. I don't know why I wrote it in that order. And simplifying this, we get to 200 minus W that we would have gotten directly from this. So we could have skipped this step had we done this step, or simplified this to this expression. So we get this times W, which is 200W minus W squared. Our area function is therefore 200W minus W squared. Now, we want to find the maximum of this area function. Okay, in order to do that, we need to identify what kind of function we have so we know what kind of method we're going to use. What type of function is this? Well, people were pretty good about this, but somebody said linear. Well, no, it's not linear. A linear function would not have a W squared in it, would it? Okay, so what is it? Well, finally somebody said quadratic, but you need to be able to identify these better than what I'm seeing right now. Okay, and that applies to things that occurred on the last test also. There's occasionally a failure to recognize a function as quadratic, and then attempting to solve something using the method you'd use for linear expressions, and that just doesn't work. Okay, so you really have to identify, and when you see this, you should immediately think quadratic. If you're not doing that, try to get in the habit. Okay, so we have 200W minus W squared is quadratic because why? It's of the form AW squared plus BW plus C. Okay, that is the form of a quadratic when your variable is W. If it was x, of course, it would be AX squared plus BX plus C. And if it was a function of t, it'd be AT squared plus BT plus C. You get the idea. You see the pattern and the form of a quadratic expression. If a quadratic expression is set equal to something, then that equation, or can be, or if you have an equation or an inequality that can be put into the form where this is on one side of the inequality, or of the whatever it is, then it's quadratic in nature. Okay. In any case, it's of this form with A equal to -1 because you got the -1W squared, B equals 200 because you got the 200W and B is the coefficient of W, and C equals 0. Now, people often miss this C equals 0 and do all kinds of interesting things with the value of C, but it's 0. And you can test that. If you plug A equals -1 in here and B equals 200 and C equals 0, well, you get -1W squared, which is your -W squared, plus 200W, plus 0. Well, plus 0, you don't even have to write out the plus 0. Okay, so make sure we understand that. It's very important. It follows then, since this is a quadratic function, that its graph is a parabola with its max or minimum value. Now, it's not going to have both. So you're either going to have a max or a min. But whatever it is, it's going to occur at a vertex. And if you know which way the graph approaches its vertex, whether upside down or right side up, then you know whether that point is a maximum or a minimum. Okay, so our strategy now for finding the maximum of this function is going to be to graph it and find its vertex and hope that the graph indicates that it is a maximum. So, how do we do that? We complete the square using the quadratic formula or we factor. Okay, we either complete the square, we use the quadratic formula, or we factor, as I said in a brief summary just before this. So, how do we complete the square? Well, there are various rules for completing a square. You can use them. I'm trying to get to the common sense of it. So when I do this, I'll do it maybe a little different way each time because I'm aiming at a fairly high level of understanding here. If you want to follow a rule, then learn that rule and follow it. But I'm trying to expand a little bit on that. Okay, so I'm first going to say that our expression is negative w squared plus 200w. Just turn this around. And that's going to be negative of w squared minus 200w. Now, why would I have done that? It's because I really want just a plain old 1 in front of my w squared when I complete the square. Okay, so we'll complete the square on w squared minus 200w, then we can put the negative in front of it again. Okay, so we got w squared minus 200w, and I'm going to say that w squared minus 200w has to be w minus 100 squared plus some constant number. Why do I say that? Well, what do you get if you square w minus 100? Now, a plus b quantity squared is a squared plus 2ab plus b squared. So w minus 100 squared is w squared minus 200w. Then there's plus that 100 squared. That's going to be a 10,000. We'll see that right here. The point is that the w squared is going to match the w squared, and the 100 was chosen so that when you double it, it matches that negative 200. Because remember, this is a, this is b, this is your 2ab term. Okay. Now, if we square the w minus 100, we get w squared minus 200w plus 10,000, and then that's going to be plus some constant number. And that's going to have to be equal to the original w squared minus 200w. There's no point in completing the square if you come out with something that's not equal to what you started with. Okay, well, we say then that w squared minus 200w then equals the square of this w squared minus 200w plus 10,000 plus that constant number. Now we have enough information where we can determine this constant number. Just solve this equation for the constant number. And you should pause and do that if you don't already see how it's done and without reading further. Okay, well, how do you do that? One way to do it is just by inspection. You got w squared minus 200w here, you got w squared minus 200w here, so the two sides match this far. Now, if the rest of it is just 0, then they match completely. Well, what's the constant number have to be to make this much 0? It has to be negative 10,000. So you have 10,000 minus 10,000, that's 0, and now this equals this, and we know what our constant number is. So we can put that constant number 10,000 here, and now we have the completed expression. Okay, and we could get more formal than that. We can subtract all this from both sides, simplify what we get, and we're left with the constant number, and that would give us negative 10,000 again. We wouldn't have to recognize it by inspection, and inspection has its limits, and it can be kind of tricky, but it's worth trying to think about what I just said about how we can get that by inspection. Okay, so by one method or another, this equation allows us to determine our constant number, and the constant number has to be negative 10,000. Well, what's that mean? That means that w squared minus 200w is w minus 100 quantity squared minus 10,000. Now you can verify that. Go ahead and square this and then subtract 10,000 and see what you get. It's going to end up w squared minus 200w. Okay, well, now what we want, of course, is minus quantity w squared minus 200w. So that, well, minus quantity w squared minus 200w, which is this quantity with a minus, is equal to minus all this. Minus our quantity w minus 100 squared minus 10,000. So we replace w squared minus 200w with quantity w minus 100 squared minus 10,000, throw a negative sign in front of it, and simplify it. When we do, we get negative w minus 100 quantity squared plus 10,000. And in that form, we easily graph it. So by completing the square, we see that our area function is negative quantity W minus 100 quantity squared plus 10,000. How do we graph this? Well, by transformations. We start with a graph of W squared, vertex at the origin. We shift the vertex over 100 units. So now the vertex is at 100, 0. We put the negative here, and that takes our parabola, which is which opens upward. The parabola W minus 100 squared opens upward, but put the negative in front of it, and that switches all our y values to negative. And now it's still got the vertex at 100, 0, but it opens downward. So the vertex is now the high point of that parabola. And then what? Well, then we add 10,000 to our y values. Now we're here as a vertex. If we add 10,000, well, that moves our vertex up to y equals 10,000, because we're adding 10,000 to every y value. So that our vertex is at 110,000, meaning that the maximum y value, or a value, the maximum value of a, is going to be 10,000. There's our conclusion. So if we graph, I just summarize all that, and you should understand exactly what this means already. If we graph by transformations, we get a parabola that opens downward with the vertex at 110,000. And we could just read the vertex off here if we understand what this function is telling us and how to graph by transformations. Now, alternatively, we can factor. A equals negative W squared plus 200W. Somebody told me right off the bat, well, factor out a W. Okay. I'm going to factor out a negative W. You get negative W times W, excuse me, minus 200. Now, we want that to be, well, we want to find the zeros, so we're going to find out what values of W make this 0. Can you see what those values are? You should be able to see that instantly. Okay, well, we got the product of two quantities equal to 0. That means either this quantity is 0 or this quantity is 0. It's the only way you're going to get zeros. And if either is 0, then you are going to get 0. So, well, W minus 200 is 0. Okay, that's what we get if this quantity is 0, so W equals 200. You don't really have to solve that equation. You can just see it in this case. Sometimes you have a more complicated expression. You would have to solve the equation, so I wrote it down that way. But it should be obvious also that if W is 200, you're going to get 0. What other value of W makes it 0? Well, people had to think about this a little bit. Somebody thought, well, 0? Yeah, exactly, 0. Okay, when W is 0, then this times this is 0. So those are your two zeros. W equals 200, W equals 0. Now, how do we use this to find the max or min, or to graph the function? Well, we've got 2 points in the graph. On the W axis, we have 0 here. We have 200 here. So here's a graph of our W axis, and we know that since the graph is symmetric, it's going to have an axis of symmetry that's exactly halfway between these two zeros, meaning the axis of symmetry has to be at W equals 100. In general, if it wasn't really simple, because you can see 0 to 200 halfway is 100. If it's less simple, if the numbers are a little uglier, you add them and divide by 2. And of course, if you add these and divide by 2, again, you get 100. So your axis of symmetry is W equals 100. Okay? Now, that means your vertex is at W equals 100, so that the area, and I've got Y here, let me pause and fix that. Okay, again, our vertex is at W100. The corresponding area is found by just plugging 100 into our function. Negative 100 squared, 200 times 100. Work it out, you get 10,000, which agrees with what you would get after completing the square. Alternatively, we could use the quadratic formula to get our two zeros. Again, we get 100 or 2, we get 0 or 100. We get the same picture we had here with the same axis of symmetry and proceed exactly as before. Now, even better, we can just use the quadratic formula directly. Alternatively, W equals negative B over 2A from the quadratic formula. We get 100. Plugging the 100 in, we get area 10,000.